Welcome to lesson 8 of this Arduino C++ course, and just like in lesson 7 we're going to be combining sensors again. This time we're going to be combining IR sensors with LEDs, and we're going to build a small project, but we're going to be combining the sensors in a slightly different format to the last lesson. So in lesson 7 we combined the PIR sensor here with the photoresistor, and we use that to control a relay and an LED. Now in that lesson both of these sensors had to be triggered above a certain level for the relay to activate. Today we're going to be using these IR sensors, and we're going to be building a sort of a simulated railway crossing where it's going to be flashing some LEDs. But instead of both sensors having to be triggered at the same time, this time just one sensor needs to be triggered. Now, because of the angle of the camera with these sensors, I've put a sensor down here so that you can see what it looks like. To adjust the sensitivity, you just need to put a small screwdriver into this little potentiometer and sort of turn it one way or the other until you get the sensitivity level you desire. Now if you want to follow along and you don't have these sensors, just replace them with a button or a different type of sensor. You'll still be able to do the project. Now, as always, there is more information available on the Digital Town site, including the download of the code and the circuit diagram. You can see it in the bottom left corner of this screen, and it should appear below the video on YouTube. So going over to the Digital Town website, to the lessons page, just scroll down to lesson 8. Obviously you've got the video. There is the circuit diagram that is exactly the same as in lesson 7, and obviously you can download the code at the end of the lesson. The only difference with the circuit today is I have actually unplugged the signal to the relay just to stop it rattling about. So today I'm going to start by showing you the finished project so that it helps you to visualize what is going on as we look at the code. So we have the two sensors, and if I put my finger over either of these sensors, you'll see the yellow LED comes on, then the red, then the yellows go off and the red starts to alternate. If I move my finger away, it will continue to run for 3 seconds. Blocking either sensor, once again, if I take my finger off very early in the process, immediately it will just wait that 3 seconds and stop the LEDs again. So all of this always works. If I just move my finger off now while it's triggering and then move my finger back on, it will keep the system running. So the system will keep running providing the sensor is triggered within a 3-second period. Now, for those who are interested in model railways and using the Arduino for model railways, you should sort of recognize something about what is going on. If we imagine a piece of railway track, we have a crossing which has these LEDs, and we would have one sensor one side of the crossing and one sensor the other side of the crossing. So as the train comes along, it will go over the one sensor. It will then keep going across the crossing, blocking then the other sensor and triggering it so that the LEDs continue to flash, and those LEDs will flash until the train has moved away from either sensor for a period of 3 seconds. Now, as always, before building the actual project, I want to check that everything is working correctly. So let's just bring the camera in. You can see that the LEDs are happily flashing away so that I know they're working. The relay is turned off just to stop the noise. And my main interest is the IR sensor. You can see as I put my finger over the sensor, one of the unusual things with these sensors is that when they are triggered, they go low, they go to 0, whereas the PIR sensor, if triggered, goes high and goes to 1. So I can now see, putting my finger over both IR sensors, that they are both working, and we now know that the circuit is ready to use. Once again, there's no point starting a project until you have checked that all the components are working individually. Otherwise, you won't know if you've got a problem with your code or with the components themselves. So now we know everything's working, let's have a look at the project and how it's going to work. So the first thing that I've done here is to write out a process. And if you're building any kind of project, this is actually an important stage to go through. Sort out in your mind how this project is going to work, because too often people get halfway through the project, they're trying to make components work when they haven't actually thought, if you like, what the process is. So this is a sort of a mental reminder for me of what we're doing. So we're going to have a project that moves through various stages or phases, or even states, as some would call it. So we're going to start off where an IR sensor is triggered. It senses the movement, it's going to go low, and it's then going to set the system into stage 1. And in stage 1, the yellow LEDs are going to come on, and they're going to stay on for 2 seconds. The system's then going to move to stage 2, and in stage 2, the red LEDs are also going to come on alongside the yellow LEDs, and it will wait 1 second. Then it's going to move to stage 3, and at stage 3 it's going to turn the yellow LEDs off and immediately move to stage 4. Notice there's no wait, it's jumping straight to stage 4, and in stage 4 the LEDs will flash, alternatively the red LEDs, at 0.5 second intervals. However, all the time, if an IR sensor is not triggered for 3 seconds, everything gets turned off. So that is the process that we're going to build. As always, I've got the sketch name, the date. I've then made a list of all the pins that are connected on the circuit, as always, and then I've got my list of outputs. So for today's lesson, we're just going to be using the red and yellow LEDs, which, as you can see, are pins 6, 7, 10 and 11. And then for the inputs, we're going to be using the 2 IR sensors, which are pins 4 and 3. Obviously, if you don't have IR sensors, feel free to switch them for a different type of sensor, or just put a button in there. As always, current millis is back, and that will be keeping the time in milliseconds since the board started. Sensor millis will keep track of the time in milliseconds for controlling the sensor timing, and the sensor timer is going to be set to 3000 milliseconds, which is 3 seconds. I've then got a byte that is going to store the sensor state, which will be a 0 or a 1. Then dropping down to the setup, again, very simple. Usual serial monitor started with the sketch name. I've got 2 inputs set up for the left and the right IR pin, and then I've got 4 outputs set up for the LEDs. So let's drop down to the loop. Coming down to the loop, I've set up 2 local variables. They are just going to store the value that is taken from the sensors. Now, I've commented out the serial print statements for these sensors because I've just checked that they work in my test sketch from the last lesson. But if you were doing this without that test sketch, then it's best to put these comments in and make sure that you are getting the correct readings from both of these sensors. Once we've got both of those readings, the next thing that we need to do is take the time. Current millis is going to be set with the board time millis, and then we're going to start on our timer. Now, thankfully, there's nothing new in this part of the lesson. From a timing point of view, we've done this sort of thing before. So as usual, it's if the difference between sensor millis and current millis is greater or equal to sensor timer, that is 3 seconds, then the sensor state needs to be set to 0. Now, the sensor state is initially set by the IR sensors, and you'll notice we've got an if statement. Now, in a previous lesson, lesson 7, we had if, and then we had an and we had a condition on the left and a condition on the right, and it meant that both of those conditions had to be met for the condition to be true. The difference here is we've got if the left hand sensor has been triggered, and then these two lines here mean or. So it's if this has been triggered or that has been triggered, and it also triggers if both of them are triggered together. Now, the or statement, those two lines are a little bit odd. I remember the first time I used them, I couldn't find it on the keyboard. And so this is bottom left on my keyboard. Obviously, I'm a UK keyboard, and it is actually this symbol here, and you need to press the sort of the shift button to get to it. So now we know how to, if you like, write our or. We've got the correct key on the keyboard. Let's have a look at the code again. So if this condition is met or this condition, so if either sensor is triggered and the sensor state is smaller than 1. Now, when the sensor state gets reset, it goes to 0, which of course is a value smaller than 1. Only then will it change the sensor state to 1. Now, you'll see why as the code progresses, because we will change the value of sensor state a number of times. Again, as long as this condition is met, we need to be constantly updating the value of sensor millis to current millis, so that at any time, if this statement becomes untrue, it's at that point that this timer line here will start to work, and it will wait that 3 seconds before it sets the sensor state to 0. Now, once all that's done, I've just put this serial print statement in, and that's just so that I can do a quick check to make sure that this is working. So the goal of this is if I trigger a sensor, sensor state should go to 1. As soon as the sensor is untriggered, it should wait 3 seconds and then set it back to 0. So let's upload the code and see how it works. So the code is now running. As you can see, the sensor state is 0. I'm going to put a finger over this sensor, and as you can see, it goes to 1. Take the finger off, wait 3 seconds, back to 0. Same with the other one. And finally, I'm going to trigger both of them together. There we go. Now, the other little test is I'm going to put my finger over this one, take my finger off, and then put it on before the 3 seconds has gone by. So I can take my finger off, back on, back off, back on. Nothing's going to happen until there is a constant 3-second gap. So at that point, we can say the code is working correctly. Time to move on to the next part. All I've now done for this next stage is added this switch statement. So the switch statement is a switch statement of sensor state. So if the sensor state has a value of 1, which would be the initial value that is set, then it's going to turn on the yellow LEDs and it's going to print out the sensor state. If it's not 1, because at the moment I've only got 1 value in, then it's going to turn off the LEDs. You'll notice I'm turning off all LEDs, red, yellow, everything's going off, although I'm only turning on the yellow. This is because at the end of the sketch you always want all the LEDs off, so I've put that in now, and obviously it's recording the sensor state. So let's just upload that code. So once again, let's do the test. Put my finger over the sensor, we can see sensor state goes high and the yellow LEDs come on. Take my finger off, wait for 3 seconds, they turn off. Put my finger on, move it away for a second, put it back on, they stay on until I remove my finger for the full 3 seconds. Now, if we go back to our initial plan, the yellow LEDs have come on. Now the goal is that the system is going to wait 2 seconds and then it's going to turn on the red LEDs. So let's start looking at how we build that little bit of code. Now the first thing you'll notice is I have added some more variables. I've got state millis and state timer. Now these have to be global variables, so they are declared up here. And the reason we need this new timer is we cannot use the sensor timer because that's constantly being used for the 2 IR sensors. So if you like, for the way that the lights will change and to take them through their different stages, we need a separate timer. And you'll notice I have not set a value for the timer section. With the IR sensors, it's set to 3 seconds. What you'll notice in the code is that this value changes because at different times the timing will change. So let's go down to the loop and take a look at what is going on. So what I've done in the first stage, I've not just turned on the LEDs as we see before, but I'm now setting up the system ready for state 2. So you remember sensor state was set to 1 if the sensors sensed movement, they were blocked off. Now what happens is we've turned the LEDs on and we're going to set that value to a 2. And that means that when this switch statement runs again on the next loop, it will start processing the code here and this code will be ignored. So we've set the sensor state to 2 so that we jump to the next stage on our switch statement. I have updated state millis, which is our new value, which is, if you like, timing us through the states. And I have updated state timer to a value of 2 seconds. So we're going to say state millis equals current millis. So that is the time, if you like, right now. And then state millis, when subtracted from current millis, we want it to have a value of greater or equal to the 2000. So this will give us, if you like, a 2-second delay. So what's going to happen? It's going to go to a sensor state of 2. The code will skip this section. It will now start running through this section, but until the timer reaches its correct state, this bit of code will not be triggered. So it will run round and round for 2 seconds going, that's not true. I'm therefore exiting here and I'm going to go round and I will keep waiting until this is true. And at that point, I'm then going to turn the red LEDs on. So let's upload it and check this bit of code. So you can see now the serial monitor, the sensor state is 0. I put my finger over, it goes to 1. You notice it only goes to 1 once, then it's going to sit on 2. Looking at the actual system itself, put my finger over, yellow LEDs, wait that time and the red LEDs come on, move my finger away, wait for 3 seconds, everything switches off. So at that point, once again, our code is running fine. Now, as always, I build my code in these little blocks of code. I test it through every single stage because then it's much easier to find the bug. If you've only written 10 lines of code, it's pretty obvious where you've just made your error. So again, I'd advise you, little steps with testing in between. So now we have the red LED and the yellow LED all lit up. Going back to the top of our sketch, the next goal in the sketch was to turn the yellow LED off after a wait of 1 second. So we want the yellows come on for 2 seconds, then the reds turn on, and after 1 second, then we're going to turn the yellow LED off. So once again, coming down to the code, we've set a timer for that 1 second. We've also set the state to 3. So now all of this code and this code will be ignored, and it will start reading case 3. And at that point, once again, the timer runs, and when the difference is 1 second, then it turns off the 2 yellow LEDs. And as we will see, as I move the video back on, I can now put my finger over yellow, red, yellow goes off. So moving to our final stage, that was once the yellow LED had turned off, we were going to immediately start flashing the red LEDs at 0.5 second intervals. Now, as there's 2 LEDs that are going to be flashing and they're going to be alternating, we need to keep track of just what is going on, which state they need to go to next. And for that, we're going to store a value in a new variable, just a byte, called flash state, because it's only going to store a 0 or a 1. So once again, going down to the main loop, all I have done now is in case 3, which is when we turned the yellow LEDs off, I've just added this line that we're now moving to sensor state 4. Now, because I want the LEDs to start flashing immediately, there is no need to set any kind of timer. So it's literally yellow LEDs off, flashing begins. Now, in this particular statement, you'll notice again, because we've got to state 4, now all the code above is not going to run. It's just going to be this section that will run. And this time I have set the state timer to 500. Now, I could have put it in the previous section, but I just put it in here because I felt it made more sense to keep this bit of code contained. And then we have a very simple system. In fact, I think we were using this on lesson 3 or lesson 4. So we're going, if current millis minus the state millis is greater or equal to the timer, which is now set at 500. We're now running this as a timer. We're going to immediately update the value of state millis so that it will trigger again in 500 milliseconds. And then I'm serial printing out the state just to test it for myself. And then what I'm doing is I'm doing an if statement on flash state. So if the value is greater than 0, then set it to 0. If the value is less than 1, set it to 1. And then obviously in one direction, set the red LEDs 1 high, 1 low, and in the other direction, 1 low, 1 high. Now, if you were doing a model railway project, you may have 4 or even more LEDs, and you may have other states in here. But I just wanted you to see how this worked. Now, because it doesn't do another sensor state, the sensor state will stay at 4, and it will keep going through this section of code until the IR sensors have not been triggered for 3 seconds. But at this point, we have a finished project. So let's get it uploaded. So here we go. I'm going to block the one IR sensor, yellow lights, red lights. Now I've got flashing lights. I'm now going to move my finger across to the other side as if the train's moved to the other sensor. Train's coming again. It's going to keep blocking this sensor. And finally, the train has gone. 3 seconds later, everything stops. So what you have there is a very simple crossing simulator. Of course, what it could really do with is a servo. Maybe I should add that in the next lesson. So a bit of a complicated lesson, but everything that you're doing or seeing in this lesson has been done before in previous lessons. The main complication is that we're now moving through a set of states. But if you want to build any kind of project with any kind of what I would call animation, where something gets triggered, it does something for a period of time, then it does something else without another trigger happening, then this is the sort of code that you need to be writing, where you move through a series of states, and in each state you can time the difference between the state, and within each state you can continue to do different things. Now, one odd bit, obviously I use the state timer here to flash the LEDs on and off. If I'd had to have a fifth case where it's going to start to do other things, then I'd probably have to create yet another timer just to flash the LEDs. Now I'm going to finish the lesson there for today, but I just want you to think a little bit about the project that we have built. So in lesson 7, we built a project using the PIR sensor and the photoresistor, and we were moving the relay, and I think it was the blue LED. Now those items haven't been used at all in today's code. Now what you could try for a little bit of homework is combine the two sketches. Take all the different variables, change the setup to make sure that you've included all the different items, and then add all of the code into the loop, and you should be able to get the PIR and photoresistor triggering the relay and the blue LED at the same time as you are able to run the IR sensors triggering the LEDs. Interesting bit of homework for you if you want to have a go. So that's it for today's video. Don't forget that the code is available for download on the Digital Town website, and please click the like and subscribe button if you want to hear more of these tutorials. So thanks for watching, and I'll see you in the next one. Bye for now.